Alright, so for a standard normal distribution is when we're using a normal distribution and it still applies in all the same ways. We just transform our data such that our mean is 0 and our standard deviation is 1. So I might have data that looks like this, where I've got a standard deviation of 10 and a mean of 60, in which case my z-scores would be 0, 1, 2 and 3, -1, -2 and -3. So all we're doing is transferring our data such that 60 becomes 0, 50 would now equal -1, etc., etc. So the z-score really tells us what? If my z-score is 1, what is that telling me?
It's one standard.
I'm 1 standard deviation above the mean. Cool?
Oh, well, that's the good.
That wasn't the gifted, yes. So the equation for z-score is x. What do you think x represents?
It's 0. Are you up?
Score of original data. So whatever we wanted to find out. So in this situation, I might say, what's the z-score when x is equal to 65? In this equation, what do you think mu stands for?
Mean.
Mean of the original data.
Yep.
And what do you think sigma stands for? Standard deviation of the standard original data set. Now the trap that people will occasionally fall into is making this 0 and this 1. That's the property, we don't shove those values in. So if you want to call it, I don't know, mu n, sigma n, I don't care what you call it, but just be aware of that. Now this has got really, really powerful things when we're trying to compare the significance. It makes it really, really easy for us to compare two data sets. So let's say here's my first exam, right? This is an exam that I've set for Year 12 students. That is the data set. Now on the first exam, Luke, we'll call this random student, scored 45. 45. So can we identify what Luke's z-score is first of all? So I want you to determine what Luke's z-score is. There we go. Negative 1.5. So Luke is 1.5 standard deviations below the mean. On another exam, it was worth 40 marks instead, right? So this is a different exam. Now Luke's got a friend and they're arguing. On this exam, 40 was the mean. But the standard deviation was 45. 5, sorry.
Sure, 45.
I don't know what it's out of.
It's 100.
Doesn't matter what it's out of.
Back over 100.
Now, Luke's friend Cooper,
30.
10.
he scored 34 on this exam. Now, Cooper's arguing to Luke that he has outperformed him, and therefore that he is the alpha of their group. Well, we're going to find out, because we want a way of comparing their results. We want to know who is actually the alpha in this scenario. Ironically, both of them are fighting up for what's probably omega.
I understand what's happening here.
Ah, you understand what's happening here. So Luke's 34. Luke's 34 is actually only.
1.2.
Oh, the stem. That's it. Sorry. That's 5, not 10. Luke's 34 is actually a better score. Sorry, Cooper's 34 is actually a better score than Luke's 45. Proving once and for all that Cooper is in fact the alpha of their friendship circle.
Wait, so the lower the better.
No.
The marks not better. The marks better. As
The marks,
compared to me.
Luke's mark looks better, but his more standard deviations below
As compared to the mean.
as compared to the
Say
mean.
test the both better 100. Luke's scores better. Luke's class just did better.
No, this is both in the same class, just different tests.
Oh.
Different tests. We're trying to see who did
So
better
one test is like.
as a relative score.
It's only relative to like the average though, so it's not actually like.
No, but
These are hypothetical people.
why would you say?
I don't know why you're getting so cut up.
So if in the same class.
Right.
So if in the same class, why don't they sit the same test though?
Yeah, but Cooper forgot what he got on that exam, and Luke forgot what he got on this
Why
exam.
can't I make
They're,
different classes?
they're a standard deviation below the mean. Come on, give them a chance. They're just trying to remember the important stuff in life. Yeah, well,
It's not really fair.
it would actually. It is important for identifying how significant a result is as well. So it can be used for that. We can do that. We won't do it right now, but we
Let's
can
do
do
it with
that.
actual data.
What's that?
We should do it with the actual data.
We actually we could do that. We can have a look.
That's accurate, it's accurate.
I will get, it takes a bit of time, but I can go through and identify. We'll go through and look at how you've gone on IA1 and IA2 and talk about your relative scores and what's a more impressive result. Because most people would have done better on the IA1, correct?
No,
So your perception around the IA1 is I've done really well.
No,
But then, if you've scored 1 mark, if you scored a lower mark on your IA2, it actually might be better relative to the cohort.
so
That's a
looking
perfect
We're
example.
looking at how well we do against the cohort or 1 to 2.
What's that?
We're looking at how well we do against the whole cohort, where we are up against the mean, or
Against the cohort, that's what this is all about. It's a sorting mechanism for determining how special your results are relative to the cohort.
Special.
Will you actually make a graph like that and show us?
Yeah, well, I don't know if I can use IA2, IA1 because I don't think it forms a normal distribution. We could potentially use the IA2 or IA3 in the external there because they do form relatively normal. Let me work on it, but that's not something I can whip up in 3 minutes.
Sorry, get it done. Right on the ball.
Okay, we're clear on that. So Z-score, you'll need to know this equation off by heart. It's not one that's given. Okay, so you'll need to know that. Just remember that these values are not 0 and not 1. They are the mean and the standard deviation of the original data set. Cool? What's it really good for? Comparing two different data sets and seeing which result is more impressive. Exercise 9.3, question 1, 11, 12, and 14, I think.
Yes, it is.
From memory, we'll start with that.